The last section for the equation, which is a Arrhenius equation. And then this one is a quite important one because actually it's a new topic for OCR and also AQA. Therefore, for surface change, whenever they add something, then a new topic, there will be a like really common topic. At least like in the last 2 years, they already has come up in the paper 1 question. And then for a Arrhenius equation, obviously they will have a 2 different format. And then you think here's like the original. And then after they rearrange and then they put Ln for both sides, then they will rearrange to form a new form, which is here. Then obviously the mathematical idea for like how you rearrange the 2 equations is not really important. Then the important is you have to understand the first equation. Scientists has like already created a graph for rate, constant, and temperature. And obviously it should be like increasing temperature and give you an increasing rate constant. That's why the rate will increase. Because from what we learned from kinetic theory, increase in temperature will have like more successful and frequent collision, and more particles can have energy bigger than EA. Then how you explain the change in rate in terms of the rate equation? Then the only relationship must be the temperature increase can increase the rate constant. Therefore the rate increase. Because obviously the change in temperature won't affect the concentration of reactant, so they only can affect the K and also the rate. But then just based on the equation here, then you only can say temperature and rate constant has a positive relationship, both increasing, but then you can't say they're directly proportional, because from the equation you can see, from the graph you can see it's like just a curve, so they increase exponentially, but they're not linear. Therefore, if a curve here, then it's like not very important or not very useful, so scientists often want to change into a straight line graph. So they will make here, and then they can put L and K as the y-axis, and then 1/50 will be the x-axis. Therefore, they can calculate 2 more things, which is here, give you the slope, and then based on the slope, you may think they can have 1 more information, which is the active radiation energy. Because if slope is equal to E over R, then just multiply it with the slope with the R, which is 8.31, to get this constant. Then you can solve the value of active radiation already. And then lastly, you have a constant here. Now, actually the constant, the real meaning is like a Arrhenius constant. But then even though you like didn't know the exact definition or the real meaning, is fine. But at least they're kind of a constant for the same reaction. Unless you change the reaction, then the A will change. Okay, you think just A as like constant for the same reaction, and it's kind of representing the frequency of that specific reaction. Therefore, 2 important graph, if you have rate constant and temperature, then just increasing, but they're not linear. Another important graph is like L and K and 1/T. Then you have a straight line graph, and this time you may think here they should have a negative slope all the time. Because the slope is like negative E over R, the negative sign is also included, so EA is positive, R is 0.31. Therefore the slope is always negative. So you may have a graph like this, or maybe like this, but then just always downward sloping. And then based on the graph, you can calculate 2 things, which is active radiation energy and also the value of A. Therefore, in the real exam, they may give you the rate equation if they want to ask you the question. But then more important is like they can also ask you what's the y-axis and x-axis that you will put in the graph, and then what's the meaning of the slope and also the y-intercept. Especially like in the new syllabus, you will have some multiple choice question. Then in the multiple choice question, other than they ask you really calculate, the value of active energy or value of A, they can ask you about the relationship. Therefore, even though you don't have to memorize the whole equation, but then at least you have to memorize like those four terms are representing by L and K and negative A over R, 1 over T, and also L and A. Yeah, you have to be able to match with everything. That will be the most important point. And in your real question, then most of the time they can ask you to do something just like what I said, which is calculating the active energy. But then here, I give you a graph, then you will think a method one, which is a kind of an easy one. You only have to pick the data point and then try to find the change of y, and then over the change of x, then I give you the slope. And then using the slope to multiply with r, then give you any activation energy. But then just remember, when you're using r, then the energy that you have will be in joule per mole, because r as a unit also in joule per mole. Therefore, here will be already a kind of one method to asking you to calculating activation energy. Yeah. So actually, for this one, it's not a really long one for this section, because like should be an easy one. And the next thing, we'll talk about something for catalysts. And for catalysts, maybe like obviously they can break down into two types, homogeneous and heterogeneous, representing the catalyst whenever they are in the same state or different stage compared to the reactant. And if you're having a heterogeneous catalyst, then you think already has advantages after the reaction. The catalysts are still in the mixture as they won't chemically change. Therefore, you have to separate the catalyst from the mixture, and then you can reuse it in the next process, in the next setup. Then if they're heterogeneous catalysts, the most of the time you should be a solid catalyst. Then the advantage will be like they can be simple, easy removed it by filtration, because they are solid form. Then the other reaction must be maybe a liquid form, maybe a gas, maybe at least something other than solid. That's why you can easily remove the solid catalyst from the mixture. Yeah. And the really last part here is actually maybe is like only for Edexcel and also AQA. But then just for AQA students, you may learn this one at the very, very last unit, which is transition metal. You may just hear, you can like kind of having a basic idea first, then when you move on into the last unit, transition metal, then you will see this one again. So here just want to show you a specific sample of catalyst, which is they can catalyst by the product of the reaction. And if something from a product and then they are catalyst, then people will call those autocatalytic reaction, because they form a catalyst already. That means you don't have to add it. Then for this reaction, specifically they will form Mn2 plus, and the Mn2 plus will be a catalyst which give you an alternative reaction pathway. And then new pathway must having a lower activation energy. Otherwise you won't call it catalyst. And then just here, more important is like I want you to understand the shape of the graph in here. And then you can see that if there's no catalyst in here, which is first low, because no catalyst, then the rate is very low. But then the first part is like that, then you can break down, and then the second part here is already, you have a really, really large increase in rate, and then based on the catalyst, which is the Mn2 plus, the income form, which provide the lower EA, then the rate will increase a lot. And then the last part here, then we think like 1 and 2 and 3. Then the rate slow down again, and then suddenly it becomes 0. Then the only reason only can be like there's no reacting, so no more reaction. So just this specific point is like autocatalytic reaction. If you haven't added catalyst, if you just let the reaction from the catalyst and then catalyst the reaction, then the main point is the first part is like really slow because you haven't found any catalyst, and even you form a small amount of catalyst is not enough. But then just after a period of time, then the rate will just suddenly increase a lot. Then give you, then based on the reason is just they have a catalyst formed it will provide the lower EA. So the other graph, the purple one, you think is just a normal concentration time graph. Just the line will become more and more horizontal based on you have catalyst already, so the rate at the first point should be the highest point because you have catalyst, and also at that point the count of reaction is the highest point. So the purple one is actually just a normal one. The rate is decreasing based on concentration decreasing based on the less frequent and successful collision because they have catalysts already. So even you form more and more catalysts, but then they already have a really low active energy, so you form more catalysts doesn't really help the reaction rate. That's why the rate for the purple one will be like very high at the first point. Therefore, you can see how I explain the effect of autocatalyst in here. And also for this reaction, how you can measure the change in concentration, then you can do one thing is like based on MnO4 permanganate is like a color ion which is purple. So people can using a calorimeter. The method to investigating reaction rate is also an important one in the new syllabus, especially for calorimeter. It's only work on for those color substance. Then using color substance, the example that you will know will be like all the halogen, and also metal ions, but then only for transition metal, just like MnO4 and Cr2O7, and then maybe copper 2 plus, Fe2 plus. Then those are color ions. But then one more special color substance I would say will be a gas, which is NO2. This one is also a brown gas. So when you see those substances are involved in a reaction, then you can using calorimeter to measure the change in the concentration, and then you can plot a graph and then you find out the reaction rate.